Hello everyone, I'm gonna show you how to find the resultant velocity, airplane and wind at this time. Here is the example. Let me read. An airplane flies due west at an airspeed of 455 miles per hour. Fire, I said fire, right? The wind blows in the direction of 39 degrees south of west at 55 miles per hour. What is the ground speed of the airplane? What is the bearing of the airplane? Right? So I draw because I wanted to save the time here. Okay. So the airplane goes to west. Can you see that? And 455 miles per hour, not a file. Okay, so as it is, as with the pictures, we're gonna find two velocity. One is the plane, one is the wind. Okay, so that is ground speed of airplane. Okay, then resultant force means we add all the vectors. So basically, vector sum is resultant force, right? Here, planes. Let us make planes. Velocity, vector. So we are using P, the first letter P as a vector notation, vector P. So I'm gonna write down negative 455. I keep thinking file. Negative 455 I, because if we think there is xy, right? This is the x, this is the y, okay? And goes to this direction, which is negative direction. I direction, right? X direction negative. So we put the negative sign. Then let me write down the wind. I want to save the space, so I'm going to write down here wind, so velocity, vector. Okay. Look, we have from the previous in the class. So if we have, let's say the vector v here. So if we say that this distance is about the vector v, then the bottom is here's angle theta. Then bottom has vector v, magnitude of vector v cosine theta, and then the vertical way is magnitude with the vector v with the sine theta. Okay. And if we're looking at the here, the picture, okay, look, then we can express the vector W will be 55 cosine 219 degree, because we measure the angle 39 there, and then there's 90, and there is another 90. So 90 plus first quadrant 90, second quadrant is 90, 180, 180 plus 39 there, then we get to 19 degree, okay? And second component is 55 and sine theta, which is sine to 19 degree. All right, so if we express this one is with ij component, so we can express this way, 55. Okay, how about, let me calculate, okay? So if we calculate this one, I get this one, negative 42.743i. Then the second one is negative 34.613g hat. Okay, this is standard unit vector form, ij form. Okay, now if we add two vectors, we are done. There is a ground speed of airplane, right? Then we're gonna find the angle theta later. So here, we're gonna find the magnitude, okay? So maybe we can do it directly, okay? To save time. So if we find the the magnitude of P plus magnitude of vector W, okay? And we get the ground speed of airplane. So this will be, let me see, I with I there, right? So negative 455 and minus 42.743 squared and plus negative 34.613. Okay, I'm squared because I'm scared I do not push the recording button. All right, then what do you get this one? Let me see what we have here. So then I have, this is 498.9. So we can say this is a 450, what's going on? 499 miles per hour. All right. This will be the first one. This will be ground speed of the airplane. Okay. Secondly, we're gonna find the angle theta. So in general, we're gonna use arctangent, right? So in order to use arctangent, so tan theta equal to y over x. Then y is j component and x is I component. So j first, j is negative 34.613 over I, where's I is negative 455. Let me just copy down the inside the radical that I component, right? So okay, then we get this one. Let me see here. It's 0.06954. If find angle theta or tangent of 0.06954, then if we are using calculator, make sure there is a degree mode. So this is 3.978. So we're gonna put the 4 degree. Okay, so this is the final answer. I hope let me write down this one. So I hope this one helps you. Thank you. Bye.